Hi everyone, today we are going to learn geometric sequence. Okay, so let's start from the general formula for the geometric sequence. Here we have un, which is our n term. A geometric sequence with the first term u1 here and the common ratio r has a general term un here, has the formula un equal to u1 times r power of n minus 1. Here you have to be careful. R cannot take these three values, okay, and u1 cannot be 0, okay. So to get their common ratio, you divide the second term with the first one or third term with the second one. This is a pattern. You can make it more, u4 over u3, u5 over u4, okay. So this is what we do today. Let's start from the questions. So find the common ratio and write the next two terms of each sequence. So first of all, let us decide which one is u1. This one is my u1 first term, this one is my u2, and this one is my u3. Okay, so how about trying this? So r equal to, we know that u1 over u2 over u1 is my r, u3 over u2 should be the same result. Okay, from this one, u2 over u1 will be 5 over 2.5, which is 2. Let's try this. u3 is 10 over 5 is 2 again. See, the ratio didn't change. Okay, so if the ratio of two consecutive terms in a sequence is constant, then it is called geometric sequence. Okay, so this is the first thing. The next one is write down the next two terms of each sequence. So the next two terms will be this. So look at this pattern. 2.5 times 2 becomes 5. 5 times 2 becomes 10. And 10 times 2 will be 20. And the other one will be 40. Okay. In this question, we are going to use TI-84 to solve the question. So the question is this: the first term of a geometric sequence is 4. As I said it before, always put all the information you have. So the first term, it means u1 is equal to 4, and the common ratio, which is my r, equal to minus 2. Determine which term has the value of 2000 minus 2480. Okay, before we go to the next stage, so let's put our formula here, u1 times rn minus 1. So okay, as the first term, so what do we know here? This one is given, u1 is given as 4, r is given as minus 2 times by, always use bracket if there is a minus number, and n minus 1. I don't know about n, I'm trying to find out the n, okay, term means here n, okay, I'm looking for n. So, and that is equal to which value we want to have this? It is minus 2480. Okay, that's the n term. Okay, now we need to figure out what is n. So here, my recommendation is to use your TI. Go to your y, this one here. Okay, and then put this down here into y. I'll need to change the color. Okay, so this one is your y. So put this down into your y. It has to go to your y. So y equal to, put this down there. Look, as you see here. And once you put it down, the next thing is try this second and graph. Okay, so as you see, when x equal to 10, here we have minus 2480. 48. Okay, so then for n equal to minus 10, this equation will satisfy minus 2048. Okay, that's the second one. Okay. So let's look at the third question. The fourth term of the geometric sequence is 54. Okay, and the sixth term is 486. Okay, we need to find out the common ratio. Let's put all the information down before we move. So the fourth term is u4 equal to 54 u6 equal to 486. Okay, we're looking for r. Okay, here always before we start, let's put our equation formula for this rn minus 1. So let's try u4 first and then u5. So u4 will be then u1 times by r, which we don't know, times by n minus 1, which is 4 minus 1. Okay, so let's rewrite this. So then u4 is 54 equal to u1, I have no idea, times by r power of 3. Okay, how about u6? Same, u1 times r power of 6 minus 1. From here I have the value for u6, which is 486. That's equal to u1 times by r power of 5. Okay, so if you just divide both of this equation like this, I'll show you here. The first one is 486 u1 r power of 5, and the second one is 54 equal to u1 times by r power of 3. So if you divide both of this together, then you will have 486 divided by 54. I just want you to observe this. If you divide u1 by u1, this will leave 1, okay? So you can cancel them. Okay, that's equal to r5 over r power of 3. So from here, let's see what we have. When we divide it, it becomes 9 equal to r5 minus 3. So 9 equal to r square. Here, take a square root from both sides. And this will be, r will have two values here, plus 3, and the second r will be minus 3. Okay, because minus 3 squared is also 9. Okay, the sum of the finite geometric series is given with this formula. Okay, so u1 is my first term, r is the common ratio, and n is the number of terms. Okay, and we have one condition here, r cannot be 1. Okay, this is really important. We'll make use of this strategy when we solve some different type of questions. So S1 is u1. Guess why? Because if I try to do it here, so let's try it, S1, so it means n is equal to 1, right? So u1 times u1 times, in the bracket, 1 minus r power of 1 over 1 minus r. So r power of 1 is just r, so you can simplify them. And from here, S1 will be u1. So let us check this question. The sum of the first n terms of a geometric sequence is given by Sn equal to 7 power of n minus 1. It means the S1 is equal to u1, which is going to be 7 power of n minus 1, 1 minus 1. Sorry, I put it down wrongly. This one, minus 1. So, if it is 1, then I will put it down here, 1. So 7 power of 1 is 7. 7 minus 1 is 6. So my first term is 6. I can get this. So second term will be 7 power of 2 minus 1, which is 48. And we know that what is the second term? How can we get the sum of the two terms? u1 plus u2, right? Is going to be the sum of the two terms, right? So I already know that U1, which is 6, then U6 will be, let's put it down properly, so this is going to be 48 minus 6, which is 42. Okay, I get this. So if I know the first two terms, I can get the common ratio. Why? Because my U1 is given as 6, U2 was 42, as we learned this in our previous slides, then the R is U2 over U1, which is 42 over 6, 7. Okay. Okay, this is the last thing we are going to learn, convergent and divergent series. And in an infinite geometric series is convergent. Okay. If the sum tends to be finite value as the number of terms gets bigger. Okay. So let's say here, let us write this down. This is really important. So I'll say here, when the sum approach a finite value, the series is said to be the convergent. Let us just write when the sum value okay, so let's go back to this. If the series is converging, then you have to keep in mind you need to use this formula, not the previous one. I'm talking about this one, because we had a formula for the sum of the geometric sequence. This formula is different than that one, because we are going to use this when the common ratio is between -1 and 1. Okay, let me give you one example, it will make more sense. So this is the series. Okay, I want to find out the sum. First of all, get the R. Your R is U2 over U1. So here 1 over 4 over 1 over 2 will give you 1 over 2. Look at this number, 1 over 2 is in between -1 and 1. So I will use this sum then. So the sum will be U1, which is 1 over 2, okay, minus 1 minus R 1 over 2. As you see, the sum will approach to 1, okay, getting close to 1. So 1 over 2 over 1 over 2 will be 1. As you see, the sum are heading towards a value 1 in this case. So we will say that this series is convergent. Okay. Thank you so much for your attention. So next video will be about proofs. See you until then. Take care.